We are now looking at limits. Remember, the first thing we do is plug it in, plug it in. If it has a value of plus or minus infinity, or if it doesn't exist, you need to say so. Plug it in, and I'd have 3 times negative 1 cubed minus 9 times negative 1 squared plus 6 times negative 1 plus 2, which is 3 times negative 1 cubed is negative 1 minus 9, negative 1 squared is 1, minus 6 plus 2, which is negative 3 minus 9 minus 6 plus 2, and it turns into negative 16. So the limit is negative 16. Now the limit as x approaches negative 2/3. Well, if I plug in 2/3, I'd have 4 times 4 minus 9 times negative 2/3 squared over 3 times negative 2/3 plus 2, which is 4 minus 9 times positive 4/9 over negative 2 plus 2, which is a 0 over 0 form. So that means algebra. So 3x plus 2, so I'm going to go ahead and factor this. This is 2 minus 3x times 2 plus 3x over 3x plus 2. These two will reduce out, so I'm going to be left with 2 minus 3x. So now I'm going to take the limit as x approaches negative 2/3 of 2 minus 3x, which is 2 minus 3 times negative 2/3. 3's reduce out, which is 2 minus a negative 2. 2 minus a negative 2 is a positive 4. Now I'm looking at limits at infinity, and if you remember, the only thing that really matters are the two highest powers. So I'm going to be looking at 5x squared over 2x squared. That's my model, which is just 5/2. So this would be the equivalent of taking the limit as x approaches infinity of 5/2, which is just 5/2. The same is going to be true here. The only two guys that matter for the model is x squared over 7x to the 4th, which is 1 over 7x squared. So I want to take the limit as x goes to infinity of 1 over 7x squared, which is 1 over 7 times infinity squared, which is 1 over infinity. And then, of course, 1 over infinity is 0.